Hi everyone. So today we are going to do this linked list question called shift linked list. So what we have to do is like it is simple. So we have this node over here. We need to shift each of the element two times. So 0 0 we need to shift it two times, first and second. So like that each of the element we just need to shift to by one. So like one five will come one position and second position, like it will circle back the end element. So essentially we will have, so for this input k is equal to 2, so each element gets shifted by 2 and in the end we get this output. So if it is 3, like each of the element will get shifted by 3 and 3 would have been the new head. So this is the question. So this is slightly tricky, so let's see how to do this one. So what we do here is, so here we have, sorry, yeah, so here we have this one. This is the input. So in the end we have the output. So first step what we do here is we need to find the three nodes. So essentially this is head is already we know, this is the tail we know, and we need to find the new tail whatever it is becoming. So in our case this is output 8, so this is the new tail will be 3. So finding new tail is fairly simple, so we just need to do this one. This whole length we need to find. We need to iterate through this array. We need to iterate through this linked list once and find the uh, one find the length, and then when k is equal to 2 we need to do length minus k. So here we'll get the new tail. So for example over here it is 6, length is 6. So and then we do length minus k, which is nothing but 6 minus 2, which is 4. So it will be first, second, third, and fourth. So this is the new tail. So yeah, so this is the first step, right? And next, the second step is find the offset. So find offset. Okay. So now, what does this find the offset means? So so this is the new tail, right? So if this new tail, so this itself is the offset. So I'll explain what is offset in a little bit more detail. So this is the offset. So for this particular thing, this is the offset, and then we need to do the shifting. So the shifting, this is the last step is, just write it down. Um, Step 3 is shift. So it is very simple. So what we do here is, so we do tail, this tail, right? It should point to this head, okay, and new tail dot next. So this is, we have this pointer to new tail. So new tail dot next, which is this pointer, it is null, nothing. It we make this new tail pointer point to null. So automatically we get this one, right? See, this 5 is now pointing to head over here. If we, this simplified diagram of, instead of writing this arrow till here, it's the same as this one. So 5 is pointing to 0 and 4 is pointing to 5, and yeah, so that's it. So this is the last type shifting. So now the tricky part here is, so what if k is equal to some very large number like 102, 103 or something. So each time, so if k is for example 102, 102, okay, instead of 2, so what you have to do is each time you need to, like, each element gets shifted 102 times and you'll end up with some something like this one, like maybe 2 will be here, 3 will be here, something. So or they'll get one more use case when k will be a negative number. So k is equal to minus 32. So if k is minus 32, we need to shift it this side. So if for example if k is minus 2, we need to shift it to the left, two elements to the left, right? So how to handle these two elements? So I think it is fairly simple. So that is when the offset comes into picture. So the offset is nothing but, okay, I'll write it down. So offset is equal to length minus k. So not just length minus k, it will be math, sorry, offset will be math dot abs of k percentage modulo operator L. So I'll tell you how this works. So this is the offset. Okay. Uh, So if we do this one, for example, we have k is equal to 2. So 2 modulo length. L is nothing but length. Yeah. So if we do 2 modulo length, I mean, sorry, if we do mat dot absolute of 2 modulo length 2 percentage 6, so we'll get back 2, right? So have if we have something like 20, let's take if we have something like okay 14, right? So if we need to shift 14 to times it's nothing but k is equal to 2 only. So if this one is 14, okay, so we have 2 over here, we shifted 14 times. 1 2 3 4 5 6 7 8 9 8, sorry, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. See, 2 comes here, same as here. So k is equal to, so how we got, so that's why we need to do modulo, like it we'll come to know equivalent to this length, right? So so we did 14 modulus length, so we got 2, so it comes down to this only. So that's why we do this one. Okay, so we take the absolute because sometimes we get negative also. So after finding the offset, we just need to keep in mind these both conditions. So if offset is equal to 0, right? The three conditions you just need to keep this in mind. So if offset is equal to 0, we can just return because there's nothing to shift. Okay. If offset is greater than 0, so in this case we need to do um, tail new tail position. See, if k is equal to 2, you can do it directly. So if for these two other conditions where it is negative and it is a big number, you need to follow these. So new tail is equal to len minus offset. else if it is less than 0, what we do is new tail is equal to offset. So that's it. So we do these three steps. So what I'll just say it again. So whenever we get this one, first thing we need to find the offset. So if this offset is 0, we return it immediately. Okay. Or if this offset is greater than 0, right? Whatever we found this offset is greater than 0, we need to do tail new tail length minus offset. So if k is equal to 2 or some other big positive number, we do this one. We did the same thing when we by like when we saw also, right? We did the same thing. We did length minus k, which I told earlier. So we do length minus offset. So we'll get 2. Okay. So sorry, uh, length, yeah. So 6 minus 2, which is 4. We get this one. So if so if it is lesser than 0, we do new tail is equal to offset. So yeah, so after this we need to do the shifting. So shifting is nothing but making this new tail point to head and new tail dot next as null, and we need to just we will get this one. We just need to return. We just need to return this head. So yeah, that's it. So these are the steps. Basically, these are the steps. So find three nodes, find offset, and shift. So let's try out this code. Add it here. The steps. So first thing. So step one. Here we are doing step one. Step one. Find the length. So head anyway we have. So next after that we need to find the tail. So to find the tail we need to find the length. So to find the length we will assign linked list p. We'll just call one variable p. We'll assign it head. We'll just move this p variable till the end. So while p dot next is not equal to null, it keeps one int length is equal to 1 since it's already pointing to head. P dot next is not equal to null. P in considering in plus 1. So with this we do p is equal to p dot next. So essentially we are just threading through the whole this thing once and we are getting the length. So next let's system dot, let's just check if this is a feature to this testing is equal to plus. So okay, it's fine, got the length. So length when until p dot next is not null, right? So p will traverse through all this and p will be pointing to the very last element. So p is nothing but the tail. So we'll write this down. Linked list is equal to tail is equal to nothing but p. So we found the head, we found the tail. So now we need to find this new tail middle element. So how we are going to find? We, how we are going to find this one? We do these steps. So first step, if we to find the offset, okay. So, so what is step 2? Find offset. Step 2. So what we do here is, I'll just copy this int offset. Okay. So then, so we found the offset. After that, if offset is 0, return. This is the very first step. If offset is equal to 0, we return next if if offset is greater than 0, we'll do one further element. Uh, int tail pass is equal to, this one we are finding this, we added this value there. Okay, this new tail position, let's call it new tail pose. Okay, so this new tail position will be len offset greater than 0 into this question mark colon. If it is greater than 0, new tail will be equal to length minus offset. Okay, no colon. Now new tail is equal to offset. So if it is lesser than 0, it is nothing but the offset value itself. So offset, right? So next, so now we finished this second step. So now the third step is very simple. So step 3. So whatever this tail, before doing all these steps, we will, this is the new head, this will become the new head. So this tails dot next will point to head, tail dot next is equal to head. Okay, so new tail. Okay, wait. So now, so now we found the position. That's all, right? So we know the position of this new tail. So in this case, we know the position is 4. So new tail position we have here, but we still don't have this new tail node, we, we don't know the pointer to this new tail node, right? So we just need to ensure a pointer points to, like this, like how head and tail is there, we need to ensure a pointer is pointing to this one. So we'll do that by doing iterating till the fourth position. So I'll just do a for loop for int I is equal to 0, I is equal to 0, I less than position, new tail position, plus plus. Okay, new tail pose is on. So now let's create linked list, new tail is equal to none. So if this new tail is null, just comment it. We already have this pointer p which we declared above. Here I'll just make use of that one. So we have this one p. So now again I'll declare p is equal to head, p is equal to head, p is equal to p dot next, right? P dot next is equal to head, p is equal to p dot next. So hope this works. Head. I think we need to make this one. We need to make this 0, 0. So 0 p is equal to p dot next. So new tail position is 4. So I0, I is less than that, yes. P is equal to p dot next. It will come here. It comes here. I becomes 1. 1 is less than 4. I come, it comes here. 2. I becomes 2. It comes here. I becomes 3. Next, I becomes 4. 4 is less than 4. This should work. So P, so linked list, new tail, we call this one as a new tail, is equal to P. Let's see if we get the correct value or not. P is equal to plus p dot value dot value p dot value 21. Just need to return head, not just return. Okay, yeah. So it's returning p dot value. So when I put p is equal to 0, it's returning p dot value as 4, but that's not the case because we want it to end over here only. This should be the new tail. So what we'll do here is we'll just put p is equal to 1. Next we'll run code. Okay, p dot value is equal to 3. Yes, now it's working properly. So after this, okay, after this, we need to go to step 3. So step 3, tail dot next. This tail dot next will point to head, right? So that's what we did over here. After this, next step is new tail dot next is equal to null. New tail dot next is equal to null. New tail dot this new tail dot next is equal to null. We will get this directly. So next, after this, before doing this, so tail dot next we might point to head. So before taking out this pointer, we will do new we'll just store this one. So let me explain. So linked list new head, we'll just call it new head. So this one is the new head, right? So what we did first step, we did tail dot next is equal to head. Okay, the second step what we'll do is before removing this one, we'll just store this one in one variable. New head is equal to new tail dot next. Okay, new tail dot next, right? It is this head. So now, so this is head. So this is the new head. So next, after doing this, we can cancel off this one. Don't need to have a reference to this. We can cancel this reference. So in the end, we need to return this new head, right? This 4 is the new head. So that's why we added this variable. So return head. So that's it, guys. So run the code. 56. Okay. Hmm, I think we forgot to do this step. I think let's add this step. Okay, we have added this step. Set is greater than 0. Is it still failing? Tail up next as head. Okay. Put -5. 1, 2, 3, 4, 5, 6. Why is it failing? Why? Absolute offset turn head. New tail position. If offset is greater than 0, to length minus offset. If it is less than 0, we just return the offset. So let's see what exact test case it's failing. This thing, screen. Okay, this is the expected output. Your code's output 0. This is my code's output 1, 2, 3, 4, 5, 0. 0, 1, 2, 3, 4, 5. Somebody said this is failing. So what do I do here? Is -5. Offset is mat dot absolute 5 percentage 6. 5 percentage 6 is nothing but 5 only. Offset will be having value of 5. 5 is greater than 0, so we do no 5 is greater than 0. Offset okay. Offset is 0. So twice it is failing. It is should I is it k? K. Okay, it's k is greater than 0. So yes guys, so it's k is equal to 0. So that's why all our tests have passed. So we shouldn't be doing offset is greater than 0 or not. Why? Because like offset will always be a positive number. So it's k, we need to check on k whether k is a positive or negative number. So if k is greater than 0, we get the correct one. See. So yeah, so these are the steps guys. So yeah, so about the time complexities. So time complexity will be um, to be of n only because we will be iterating. In the worst case we will have to iterate the full length, right? So like we'll be to shift these things, we need to shift all of these things, and also it will be of n. And space complexity wise, we didn't create any new output arrays or linked list or something, so it will be of 1. So time and space complexity will be of n and O of 1 space. So yeah, that's it guys. Thank you for watching.